Greetings! Today we're going to cover how to run studies online in Pavlovia and common problems that arise when trying to translate a working study to Pavlovia. So I've created a little demo experiment here, which I'll run in a moment. But first of all, I just wanted to orient you to what I've actually put in this experiment. First, we have a welcome screen, and on this welcome screen, we have simply a message that says welcome to the demo. I've got some code here, which we'll take a closer look at later today, but this is basically just some Python code that takes two lists and combines them together, and this is going to form our stimulus list. And I have a little redundancy in my code because I want to show you some different ways that your Python code needs to be translated into JavaScript so that it runs properly online. Afterwards, basically the experiment just shows 8 pictures, and those pictures are either a colored square or a fruit, and then the experiment ends. And so there's a little bit of a loop here, and I have it set up such that my loop is dependent on code. So the image file that's actually loaded in, there's no Excel file here that identifies which images should be loaded. Instead, in the welcome area, the lists here identify all the stimuli that are going to get used in our experiment. So let me just quickly run this so you guys can see what this experiment actually outputs. And then we'll take a little closer at all the code. So here's my welcome message. I press spacebar, and then I get either colored squares or fruit. And there's 4 colors and there's 4 fruits. And it's randomly ordered every time I run this experiment. So a very basic experiment. How do we actually run this on Pavlovia? So if you want to run this experiment on Pavlovia, the feature is built into PsychoPy here. First of all, if you haven't logged in Pavlovia before, you want to make sure to go ahead and log in over here. I have a few logins here. Actually, oddly enough, there's my name misspelled. I don't know why I have that as a login, but anyway. So if you'd like to actually run your experiment on Pavlovia, the first step is to just click this Run the Study on Pavlovia icon. This is sort of the web run option, so the web play. And there's also a sync button, which we're going to be looking at a little bit today. Now, when I click Run, I'm going to be told that my file doesn't belong to any project, so I'm going to create a project. And I'm going to call this the Pavlovia demo. Now, you should take care whatever you name your experiment is going to be part of the URL that you're going to be giving to subjects. So make sure you're naming your experiment something that you actually want to use. The rest can just be left as is. I mean, you can select a specific user, but it's just going to default to me. If you want your experiment to be public, you can do so. My experiments, I don't usually make public like that. Maybe you want to for some reason. Anyway, when you click OK, what happens is that now PsychoPy scans the folder where you've got your experiment, and you can see it's identifying 34 files. Well, if we look at the folder where I'm running this experiment for just a moment, you'll see that, first of all, here's my experiment, my PsychoPy experiment file. Here's the last run Python file that's normally generated when you just click play and run your experiment locally. When you click to upload to Pavlovia, you'll generate these 2 extra JavaScript files, the .js files. The index also gets generated, and the gitignore. This resources folder, this is where I've got my pictures of colors or fruits. And I have a data folder from every time I've run this. So this is just stuff that doesn't really matter, but looks like it's going to get uploaded because 34 files were found. Basically, when you click this play button, everything that's in the folder where you've got your PsychoPy experiment saved is going to get uploaded to Pavlovia. So what I really recommend is that every experiment you create that you intend to upload to Pavlovia, you put it in its own folder. Give it its own folder. Also, any resources, so pictures, sounds, movies, that you actually want to have access to online need to be in a folder called resources. All lowercase. It's very important that you actually put things in a resources folder. I mean, there are ways to load images that aren't in this resources folder, and we'll take a quick look at that today. But by default, PsychoPy and Pavlovia are going to make available all the files in your resources folder to your online experiments. Full images and videos and stuff that are in different named folders are not by default going to be accessible. So save yourself some trouble. Start putting everything in a resources folder that you want to load. So all your pictures and stuff. Anyway, we can just go ahead and click OK. And what's happening now is my experiment is being uploaded. Then pushing files to Pavlovia for the first time, and we get a bit of information and then a success. Now, automatically, a web browser window should have opened up once the files were uploaded, and you can see here was the name of my experiment, Pavlovia Demo. So you can see here's the URL that I would give to subjects. Now, notice that nothing is happening. You might think that you've done something wrong, but this is actually completely normal. What you have to do now is go to your Pavlovia dashboard. So if you click on your Pavlovia dashboard, you'll be brought to this screen. You might have to log in before getting here. But clicking on your Experiments tab, you will now see all the experiments that you have access to. And so here are just a variety of other experiments that I've been working on for different folks. Here's the Pavlovia demo that I just created, though. And notice that it's inactive. So the first thing that we have to do for a new experiment is change it from being inactive to being active. So right now it's inactive. I'm going to click on piloting to put my experiment in a piloting mode, allowing me to test it, but right now subjects can't access it. The piloting mode is also special in that every time you run the experiment through piloting, whenever you close the tab or reach the end of the experiment, the data from your session will be automatically downloaded to your local computer. When you are in running mode, this isn't the case. When you're in running mode, every time a subject completes your study, the data is saved to a database, which you would come in here and click on Download Results. So download results will get access to all the data collected through running. For piloting, no data is stored in the database, and everything is stored locally to the user who was launching the experiment when they were piloting. Now, one bug can arise here. So I guess I should say, once your experiment's in piloting mode, to actually pilot it, you just click this pilot button. And this will actually go to run your experiment. Now notice here that still nothing is happening. If at this stage you get a 403 error, so it says 403 experiment not found, something like that, what you need to do is come over here and click inactive, and then click piloting again. And then usually that will fix the issue. And then you can go ahead and click pilot. My experiment still isn't working, and it's because I've intentionally designed my experiment to fail online, because today we're going to be looking at how do you fix your experiments when they won't run in Pavlovia. So when you are working with experiments in Pavlovia, it's important to know where error messages are going to appear. When you're running experiments in PsychoPy, all your output is going to come over here. So if, for instance, my code had a bug, for instance, this line will not execute. So that is going to crash my program because that is just a line, just sentence that I've inserted. So notice that it says here, you've got an error on line 95 in your experiment. So this line will not execute. It's a bad line. So I can go in here and say, okay, I'm going to get rid of that, and that will fix my experiment. So knowing where errors occur is important. And in the web versions, you're also getting errors that are telling you when things aren't working. It's just that you can't see them by default. Where you find these errors are in the console. And so if you're using the Chrome web browser, you can click on the menu, go to More Tools and Developer Tools, and this will bring up your console. Now you can see that we've got a problem, and it's giving me a line number, and if I click it, it should. In this case, it doesn't want to. That's okay. We're gonna be using this console a bit more today, and basically the reason my experiment doesn't work right now is because all that lovely Python code that I've included, none of that can be translated to the web. And so our first lesson is going to be what code actually is translated to Pavlovia and what code isn't. But here's where generally you will see error messages. It is in the developer tools, and then if you end up on a different tab here, you want to go to the console, and this is where you'll see errors. So we have an error. That's why our experiment isn't initializing. You can also get to the console here by pressing Control-Shift-I. So Control-Shift-I will turn it off and on. I'm toggling it right now with Control-Shift-I. Okay, but let's return back to my experiment and figure out why it didn't run to begin with. So let's take a look at that code. So first, let me give you a little overview of what's happening in this code here. So we have a couple of functions here. We have a function called join lists, and it's just going to take list 1 and list 2 and combine them, and it's going to use a for loop in order to do that. I've got a print statement here, which will print some nice output into my output area so I know what's happening. I create an empty new list, and then for each item in list 1, I print out that item, so I get some user output, and then the new list, I append my item to the end of the new list. So I'm adding it on to the list. After I finish with list 1, I do the same with list 2. And so my new list is basically list 1 and list 2 combined together in that order. There's another function here called join list using the plus operator. It's very similar. It takes list 1 and list 2, and in this case, it just uses Python's operator, the plus symbol, and this will actually have the same output as what I'm doing up here, and it will take list 1 and list 2, and it will add them together, so you get a nice big list that contains all the items, and that is returned to the user. I have a function here called print list, and this just takes in a list, and what it will do is it will loop through the list, but it does a different kind of loop. So this for loop uses Python's ability to loop through items in a list. This for loop down here actually uses an index counter. So this counter starts at 0 and goes up to the length of list 1, and it prints out list 1 at index I for each iteration of the loop. And frankly, this is actually a more traditional way of using a for loop. This method of directly accessing and looping through the items is something that's a little unique to Python. So as we will see in JavaScript, this is actually an easier for loop to translate. This one is actually, there's no direct translation in JavaScript, but there is a way to translate it. All right, so those are the functions. Those are our helper functions. We're also importing the random library because we're going to use the shuffle command to shuffle our list at the end. But moving down here, what we're doing is we have two lists, a color list and a fruit list. And each list has 4 items, and these are going to be our stimuli in our experiment. We join our lists together using the join lists for function up here. And then we print that list out using our print list function. And then we do the exact same thing using the join list plus. So this is a little redundant. The experiment would work just fine if we only had this and if we only had this. The only reason I have it doing the same work twice and then overwriting that work is so that I can show you multiple conversions of JavaScript that you need to do for these different kinds of list manipulations. In any event, once we have our joined list, we've generated it twice here again, kind of redundant, but once we have it, what we do now is shuffle that list using the shuffle function, then we print out the final list. So if I go ahead and run this experiment locally here in Python, once we get to our welcome screen, we don't even actually have to run the experiment because all this code gets executed at the beginning of the experiment. I can come down here and we can look at the output of everything that we just did. So we use the join list for function and it looped through the first 4 colors and the first 4 fruits. We then printed out the list using our print list function. We use the join list plus function, and this is showing list 1 and list 2, and it's going to combine them, and so we get the exact same output that we did when we combine things using the for function. And then we shuffle our list, and now you can see we've created a unique order. The rest of the code in the experiment is pretty simple. We have a loop here. Actually, let me show you the image object. This is an image object that is simply showing whatever the contents of image file are, and every time the loop repeats, it updates this. So image file is set to be equal to resources slash the stimulus name.png. And if we go back to our resources folder, here are all the images. So apple.png, banana.png, grape.png. So we had to add the resources slash to indicate that here's where our experiment's running, and look in the resources folder and then look for apple.png. And that's how we generate our image file that's going to be used for our stimuli. So you do need to specify which folder to find your images in. And again, by default, Pavlovia is going to make the resources folder available to your online experiments. If we had, say, an images folder over here, like this, and we put all of our images in there, and we tried to run things in Pavlovia, if we instead had here images slash apple.png, we'd get a file not found error. Unless we added in some code to specifically load in the images folder. So because Pavlovia by default is going to load in the resources folder, put your images in here. The other thing that I want to point out is use these forward slashes like this, even if you're on a Windows computer. If you use backslashes like this, first of all, you have to use a double slash or you're going to get an error. But second of all, it's just things don't always translate well when you're using the backslashes like this. So just use a forward slash. It's universal, translates well to the web. So make sure you're using forward slashes. You might get file not found errors if you're using backslashes. And again, you'd have to use 2 actually in a string. Anyway, forward slash is just fine for us. Oh, actually, I wanted to show you. So every time this routine begins, let me shrink this a bit. Every time this loop begins, in fact, we generate a new image file value based on the final list that we had shuffled at the current image. So that's our index. And at the beginning of the experiment, we set the current image to be 0. So every time our loop, so when our loop begins for the first time, we're going to grab the 0th or the very first item in the join list array. And so what we need now is a way to update current image every time the loop ends. So if you just go to the end routine, I've got this one line of code. Current image is plus equal 1, which means increment it by 1. And with these 3 little bits, we will loop through all 8 joined list items and show them. And we have set the number of repetitions of our loop to be 8. So that makes sure that we're going to go through all 8 items that we've loaded in. If you have trouble following this code, you should go back and look at some of the other videos that I've produced showing you how to manipulate lists and write stuff in Python and so on. And you can look up general tutorials on, loops and arrays and all sorts of stuff in Python. My goal here today is not to cover all of that stuff because I want to cover the Pavlovia stuff instead. So if you're getting lost at what the lists are doing, go back and take a look at some of that stuff. One other thing I wanted to point out here, and I can show this to you without even uploading the experiment. This is an error that can arise locally, is the order in which you have your code and your objects matters. So for instance, in the begin routine section of this code, I am creating a variable called image file, and I'm giving it an image that exists on my computer to load. This image object is going to look for an image file variable and use that in order to display something to the screen. Now, the way PsychoPy works is it's first going to deal with stuff in the code when the routine begins, and then it's going to deal with stuff in the image, because that's the order in which they exist in this routine. If, however, the code occurred after the image, then think about the logic of what's happening. Your experiment's going to try and grab the variable image file, but that variable is not going to be created until after the image has already tried to draw to the screen. So if we have our code, which has the key script that is creating the image file variable after the image, well, this is just going to crash. And I can show it to you. We're going to get a variable not found error. It's going to say image file doesn't exist. So this is sort of an error that I've seen people make. They say, what, image file? What do you mean it's not defined? I've defined it right here. Well, you've defined it after you've created something that wants to reference it. So you have to create that variable first, then you can reference it. So the order of items here matters in terms of, what's going to be executed at certain points of setting up a routine. So that's just one little error that could have arisen if you were to try and replicate my code, if you put things in the wrong order. All right, so let's return to the bigger mystery of why things didn't work. Well, the reason that my experiment didn't do anything online is because this is a code-heavy experiment, and Python code does not run in a web browser. What you need is JavaScript code. So what is pretty common for people to do in PsychoPy, because it's PsychoPython, is to write experiments in Python, and then when you want to run them online, you need to basically have both sets of code. You need to have the Python code, which is what the experiment's going to use to run locally, and then you're going to need the JavaScript code, which you're going to run, which is going to be used to run your experiment online. And so often I think the default mode nowadays for PsychoPy is to have auto to JavaScript. That's what this is, auto to JavaScript. So basically anything you write over here will automatically be translated to JavaScript. So maybe thinking, okay, so I just click that auto to JavaScript. I go in here, I make sure this is also on auto to JavaScript, and everything looks good. Now I can click run on Pavlovia and my experiment's going to run. By the way, this is also demonstrating how you update an experiment. So after you've made some changes, you click on the online play and it will say, hey, there's some new files and some change files. We're going to upload these. You can make notes to yourself about what changes have occurred, but I usually don't bother. And this will now upload to Pavlovia. And when it's ready, it will automatically open up. Notice that once again, it's still not working. If we open the console here, we're still getting errors. And it's odd that this does not, normally you can click this and you can go see the error, but let's start trying to dissect why the JavaScript isn't working, because certainly the experiment's not going to be working just yet. All right, now when you do click to run an experiment online, PsychoPy is going to open up a new window which actually contains the JavaScript that was generated for your experiment. So none of this really matters for how your experiment's going to appear online. It's only this stuff that determines how your experiment's going to run. This stuff here determines how the JavaScript file is generated, but ultimately it's the stuff in here that can direct you when you have an error. So we were told we have an error on line 109. So if we come down to 109, here's the problem. Import star as random from random. And this is the first line of code that was automatically generated when we told PsychoPy to take our Python code and translate it to JavaScript. So what we're going to learn today is that the automatic conversion of Python to JavaScript can work in simple cases, but it often fails and breaks down, and sometimes doesn't even break down, but produces very sort of messy and hard to read code. Now, it is actually fairly remarkable that the program does the conversion. But at the same time, if you are going to be running experiments online that use a lot of PsychoPy inline code, you're going to have to do a lot of translation yourself. It's just the way it works. The auto conversion just isn't where it needs to be, where it's going to get it right all the time. So when it's on auto, you can't make any changes here. So instead, you need to change it to both. And now you can make changes. An important thing to realize is if you go in here and you say, add a new line of code, it's not getting added over here. So the code that you're now writing, once you have it on both, the code you're writing in Python, the code you're writing in JavaScript are different. And so if you make a bunch of changes over here and you don't go ahead and add them over here, your local experiment and your online experiment are going to run differently. So another thing you got to keep in mind is it's up to you to keep the code equivalent and make sure that things work the same. Okay, first things first, if you have any imports, they're just not going to work in JavaScript. So we're just going to get rid of that because that's just not going to work. Generally, you want to try and avoid importing anything into PsychoPy because it really doesn't translate online. And so, for instance, if you use something like NumPy, which is a common library in Python, there's just no equivalent in JavaScript. So you're going to have to figure out different ways of writing your code in JavaScript to get equivalent results. Another thing to notice is that in Python, you can just start using variables. So for instance, when I said color list is equal to red, blue, green, and yellow, I hadn't defined color list anywhere. I just started to use a variable called color list, and Python realized, hey, he's using a variable. I should make that a variable and take care of all the work defining it. In JavaScript, you actually have to define your variables. So you need a statement like this, var, and then any variables that you want to define. You don't have to say anything more about them, and then later on you can use them. But if we did not have this statement, and we just said color list is equal to red, blue, green, and yellow, and you try and run this, you're going to get an error saying that color list is undefined. So you need to actually define your variables. And notice, even within functions, I'm defining variables. Like here, I just said new list is equal to nothing. Here I have to first define new list as a variable, then I can say it's equal to nothing. Another difference between Python and JavaScript is that rather than print statements, you have console.log statements. These are equivalent to print statements, and anything you put in here will appear in your console log that we saw before, rather than the sort of output area that Python uses. So console.log is a very important function to know about, because as you are developing scripts, you're invariably going to have errors, and you're going to need to track down those errors. And it's helpful to print out the values of certain variables and see what are they equal to even. Did they get assigned properly? So you're going to want to know about console.log. Okay, and so this brings us to our for loops. So I said before that one of the reasons I have two join list functions is that I wanted to kind of show you guys different ways that you can write loops from Python into JavaScript so that they work. So first of all, here, this was an interesting loop where I said that there's actually no JavaScript equivalent for this kind of for loop from Python. And as you can see, PsychoPy has created a very convoluted and complex for loop that tries to get the same output. And actually, I believe this would work. But since you have to write your own JavaScript code, it's better to make things readable for yourself. So first of all, if you have comments in your Python code, add those comments to your JavaScript code, just so that you can actually still follow what it is you're doing. Second of all, let's try and simplify these for loops a little bit. So I'm just trying to get my function here to look as similar to what I've got over here, so that later on when I'm looking at my different code, things look equivalent. And actually, you know what? Let's come back to these for loops. Let me show you the way that for loops work in JavaScript first, and then we'll come back to why these are kind of funky loops to recreate. But the print list function here, this has a for loop that is actually a little cumbersome in Python, but is actually the more common way that you'll see for loops across different programming languages. So in JavaScript, for loops typically begin with assigning a variable like I to be equal to 0. Then you will say you will give it some maximum like I has to be less than 10, and then you will give it something to do on every step. So you'll say I increment by 1. That's what the plus means. So this is the more common structure that you see in for loops across many programming languages. A variable that gets a default value, a condition to check, and once that condition is false, then the loop ends, and something to do at each iteration of the loop. So this will basically create an I variable that starts at 0, counts all the way up to 9. When it reaches 10, it is no longer less than 10, and so the loop will end. So we'll go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we don't actually want to go to 10. We want to go to we want to go through every item in list 1. So rather than going from 0 to 10, I'm going to go to list1.length. This is the JavaScript script equivalent of get the number of items from list 1. If I do this, then this function will now essentially translate. Another thing that PsychoPy does is it introduces a lot of parentheses when it's doing the translation, and frankly, they just aren't necessary and are a little confusing. So I'm just going to get rid of them for simplification. You can see, by the way, that another thing that's different is rather than using the str function to convert an integer to a string, you take the integer and you use the sort of built-in class function of dot to string. So this basically now has fixed our print list function. So now it will first output the statement printing lists. It will go through the numbers 0 to list length, which is what it was doing up here. And then for each item in the list, it will have a print statement indicating which item it is and what the value is. One other thing to note is that in Python, you indicate that code belongs within loops or within if statements by through tabs and tabbing and white space, right? In JavaScript over here, it's actually indicated through squirrely brackets. So actually, we don't need to, we don't need to play by Python's rules in terms of white space. Like this will work, this will work, this will work. All of those work because JavaScript doesn't care about white space and tabs. But for readability, and again, to keep things comparable, I recommend you don't get all funky with your tab stops in the JavaScript and just continue to follow your Python indentation rules. But you will need squirrely brackets for a for loop. Other than that, again, this function has been translated. So, okay, now that we understand how for loops work, again, and this is the only way they work in JavaScript. In Python, for loops iterate through items in a list, so you can get them to iterate through numbers, but you can also just get them to iterate through the items themselves. For loops only iterate through numbers, essentially, in JavaScript. And so how do you sort of take this structure of a for loop and get it to behave like we've got over here? And so let's return back up here, and we see that there is a complicated system going on here where we're actually defining multiple variables at the beginning of our for loop. We're making an odd check here with variables that kind of have like no name. And so the system has named them. They're like system variables, and we're still incrementing a counter as we were doing before. And then we're grabbing the item in a way. This, by the way, would work. This is all fine, but what I want to encourage you to do is write more readable code. And also this will help you understand what is actually going on in this loop. Because really, we're not actually going to reinvent the wheel. We're just going to take this and make it easier to understand. So we're once again going to use the variable I. And we're going to say I is less than list1.length I++. So pretty much the exact same for statement that we wrote before. But we're also now going to have a separate line here where we assign the item variable to be equal to list1 and item I. And we can get rid of all this now. So again, much more readable, but it's essentially the same thing that PsychoPy had auto-translated. And so rather than in Python actually iterating directly through the items in the list, here we're iterating through the list length itself, and we're grabbing the item at different list positions based on where we are in the loop. And we can get rid of these extra parentheses, and that's essentially it. We can do the same thing down here if we want. We're going to iterate now through list 2, and item is equal to list 2 item I. And we can get rid of the extra parentheses. So you can see it's not too bad to make the conversions. And we've got down here, so we're going to have a different correction we have to make here. But we just have to make sure that things are converted. Because again, all the code in here does not go online. It's only code that's written in JavaScript that will end up online. So it's only stuff on the right here. So we could change the left all we want. It's not going to impact online at all. And so that's why the experiment didn't work at the beginning. There was no JavaScript code. I'll grab the wrong comment here. Just adding in comments as we go so that my JavaScript is just as readable as my Python code. All right, so now here, this is join list plus. So first of all, we're defining our variable new list. That's fine. Then we're printing the list that we're going to combine. That's fine, using console.log. Then our new list. So JavaScript doesn't allow you to have list1 plus list2. It's just not going to work. In order to get that output, you need to use a function for a list called concat. And so this says list1, for list1, concatenate onto the end of it list2. And that will give you a new list that is basically one list plus the other, and then we can assign that to new list. So this is the same output as list1 plus list2, but you have to use a different syntax in JavaScript. Okay, other than that, there was one other correction I forgot to note, and that's up here in the join list for. We fixed the for loop, but JavaScript doesn't have a function, doesn't have a class function called append. Instead, that's called push. So push is how you actually append an item to the end of a list, and PsychoPy just doesn't know that, so it leaves it as append, and that is an error. So you have to change your appends to pushes. Okay, other than that, let's scroll down to the very bottom and see if there's any other corrections we need to do. We're going to correct the spacing and add in our comments so that things are nice and clear for us. And this looks more or less okay. Again, we're going to get some errors, but we're going to step through all these errors incrementally so we can see how to fix them. Okay, we actually have some JavaScript code now. Let's just run it online and see what happens here. So we click the online run, 2 files were changed. Now, sometimes you'll get this when you're working in Pavlovia. The JavaScript window that's open, when it detects changes, it will say, do you want to reload? Just click yes. It kind of pops up at annoying times. I wish it wouldn't pop up all the time, but you can't stop it. Anyway, we click OK. It's going to upload to Pavlovia, and in a minute it will open in our browser automatically, and it's still not going to run. But now, notice that it's a different line that we're getting an error, line 153. So let's go over to our JavaScript here and go down to line 193 and see what error we've got. And actually, there's no error there. I think the error is arising from our code because, yeah, we've got too many close parentheses there. So when you get a weird error in your code that's indicating an unexpected close or open parenthesis, and you go down and it's, I mean, this is code generated by PsychoPy, so this shouldn't be causing any errors. Chances are you had one too many open or close parentheses earlier on, and that's the error. Here's one other thing you can do, by the way. You can actually make changes directly to this JavaScript file and just go ahead and sync your changes to Pavlovia directly. And if your experiment now works, then you can run your experiment and everything's good. The thing is, the next time you actually click here to run your experiment, you're going to regenerate all this code, and your error is going to be reproduced. So it's handy to know that you can directly edit the JS file and then just upload it. But really, if you make a correction, you want to be making your correction in your actual PsychoPy experiment. So we're just going to fix that, and that should basically fix everything. So go ahead and propagate those changes. And now, hopefully, we at least get a different error. Again, I'm still expecting us to have a couple of errors, but let's see where we get. Aha! Okay. When you go to run an experiment in Pavlovia, and it's in piloting mode, when you click the play button, the play on Pavlovia, it's never going to run. It's always going to give you this piloting error. This is actually good. This means our experiment works. It's just, in order to actually run it, you need to come over to the dashboard and click on pilot. The reason you have to do this is because you get this special pilot token that allows you access to the experiment. When the experiment's in piloting mode, if you give this URL to someone, they can't run your experiment. If you give the entire thing you get when you click on pilot to someone, then they can run it. So if we go ahead and click on OK, we're going to get an error here. So that's fine. But we're making progress. We actually got the experiment to start up, at least on in Pavlovia. If we open up our console, we will see, okay, we have a problem. For join lists, item is not defined. Oh, so I messed up something in my join list. And notice that I have an error here on line 134. Now if I click it, okay, I don't know why it wasn't working before, but I guess when you don't even get your experiment to start up, it's not going to let you just click. So if you click here, it will actually take you to the line where the error is occurring, and it is occurring on line 134. Oh no, wait, sorry, that's the actual output that is coming out of our experiment, and that is fine. So our console.log is printing that statement out, so that's fine. So our error is actually coming in at line 180. Or no, 138, sorry. You'll see these various lines coming out. It's basically tracking the error back because when code is called in JavaScript, there's like code that calls a function that can try to do something in that function, and the error itself is always the sort of first line that you can identify in your code here. So for instance, right here, this would be the error. So this is line 138, and here we go. Aha! Remember what I said about JavaScript. You can't just start using a variable without first defining it. Nowhere in this function have we defined item. We've defined new list, but not item. So we have to go back in here, back into our experiment, into our code, and because we're using a variable called item, we can fix it multiple ways. We can do this by defining the item at the start once. We can define it right here if we want, and we'd have to define it here too. Actually, I guess we wouldn't, but in any event, wherever you put the definition for the item is fine. Let's just have a general one at the beginning of the function, but we do have to define our item. Let's just double check we didn't make that error anywhere else. Not really. So we should be okay. Okay, let's try running this again. Pushing our changes online. Once again, we get this error, and that's fine. We're expecting that. We go back to our dashboard. Notice, by the way, we just downloaded our data. When we're in piloting mode, every time we terminate or end an experiment, our data gets saved. We're not going to be looking at data here today, but that's just what is supposed to happen in piloting mode. Okay, good. We made it a step further. Now we have a different error. Oh, and notice, by the way, here's all those text outputs that we saw in PsychoPy. So console.log, the console is where things are being written out. And notice that the console prints arrays and lists a little differently than how Python does it, but they're still there. So this is all equivalent code to what we had before. All right, so now we've got a problem. Random is not defined. So if we go to line 189, we see our shuffle statement doesn't actually work. Now this goes all the way back to the first line of code that JavaScript or Python generated for us in JavaScript that didn't work. The import, oh yes, this is popping up again. The import random, and I just deleted it and I said don't even use it because it's never going to work. And it's true. So if you want to use random functions in JavaScript, you have to use a math.random function, and you can look that up. There's plenty written on JavaScript and how math.random works. However, there is actually, if all you're using random for is shuffling lists, there's actually a little shortcut you can use in order to get shuffle to work. And that is to basically, at the beginning here, define shuffle as equal to util.shuffle. And util.shuffle is a utility function in the online version of PsychoPy that will shuffle lists for you. And in fact, if we go down to our shuffle command down here, rather than having random.shuffle, we can just have shuffle. And that will sufficiently shuffle our lists. So, all right, another problem solved. We're going to go ahead here and once again propagate our changes online. 2 files changed. And once again, we get our piloting error. That's fine. I click on pilot. And now we're getting to the welcome screen. Huzzah! So all the code in our little welcome area now works. And if we go into our console to take a look, we see no errors. We see that all those print statements that we wanted are printing out information to us, so we know that things are working. Okay, let's see what happens if we try and go a step further. Uh-oh, cannot read property of 0, undefined. We've got another error. So this is occurring at line 509, and if we go into line 509, we have image file is equal to resources joined list. This is the code that we had that actually created our image file variable. And what it's saying is cannot read property 0 of undefined. So we're trying to read the 0th item from this list, but this list is undefined. And that's what this error is saying to us. Now you might be saying, how is joined list undefined? I thought the welcome screen defined it. And this brings us to one of the big quirks of Pavlovia and JavaScript over Python. So if we look into our welcome code, we had our 2 lists, and they were combined together into a join list and then shuffled. And then later on, we took that joined list and we grabbed items out of it in order to present our stimuli to subjects. Now, actually, while we're here, we can go ahead and get rid of these extra parentheses here. Oh, this is on auto, so I can't edit. I have to switch it to both. So we'll get rid of these extra parentheses. There we go. So the syntax-wise, it looks good. But why is joined list undefined here, but not here? And the reason is because generally speaking, in Python, all variables are global and accessible throughout the experiment. So if I make a list called join list here at the beginning of the experiment in code welcome, then that is accessible over here. In JavaScript, however, things don't work quite the same way. Notice up here that we're actually defining our variables, color list, fruit list, and joined list. I said before, you do have to define your variables in JavaScript. But what's actually happening is these variables are being defined within a function. So it's kind of hidden from us, but everything we've written in here is actually going to go in a function that JavaScript is going to call when the program starts. Whereas all the code here is just run in sort of the base scope of Python when this is put into PsychoPy. So the scope is different here than here. So you've got scope issues here. Another way to see it is if we go over here into the actual JavaScript, we can look down and try to find our code. Oh, and it just updated on me. So let's scroll down here. So we have experiment initialization. And in here, oh, look, all our code is starting to appear. So this is the code that we have at the start of the experiment. That's good. We do want it to occur at the start of the experiment. But notice it's occurring within a function, meaning that these variables that we've defined exist only in this function. And once this function ends, once the experiment starts, they all disappear. And so that means if we try and call joined list later on, it was erased basically when this function ended. So that's kind of a problem for us. One way around it is to basically get rid of these local definitions. So PsychoPy includes them, but if you go and look in your actual JavaScript file, you'll see that outside the function, so in the global scope, we actually have variables called color list, fruit list, and joined list. And so actually, we can pretty much just get rid of this line. We can delete that. And now You may think, okay, but colorless, it has to be defined, right? Well, it's defined in the global scope. And the way JavaScript works is if it can't find a variable locally, it will check the global scope. And if it can't find it there, then it's undefined. But if it looks for a variable and it finds a local definition, it will only work with that. And so the global definitions will remain undefined. So you're wondering why joined list was undefined, and it's because the joined list that we actually created when we started our experiment was a local version of joined list. It wasn't the one that existed in the global context. So it's an easy enough fix. We're going to go ahead and delete our local definitions of those lists. We're not going to get errors though, because we can see in the JavaScript file that it is actually creating global versions of those variables. And these versions now are the ones that are going to get assigned when we start our experiment, and these versions are the ones that are going to get pulled later in the experiment, and now they're actually going to have values. So we can go ahead and save this, run it online, get our handy piloting error, and now if we click on pilot and click OK, and now we're at the last step, the last error that we're going to encounter here today, unknown resource. So I said that you want to include all your resources in a resources folder so that PsychoPy loads them in automatically. I don't know why Pavlovia and PsychoPy are not automatically loading in files that are in the resources subfolder. Maybe someone out there can correct this for me. I mean, if you look at Pavlovia's or PsychoPy's own documentation, it says that everything in the resources folder is going to be loaded in as a resource and preloaded so that it can be accessed. But that just doesn't seem to happen often with PsychoPy. So this is a common error to get. You're not going to get it necessarily every time. But when you get this error, how do you actually fix this? Well, the way you can fix it is you can manually load in different images from your resources folder to make sure they get preloaded into your experiment. And before I actually show you how to do that, one other thing I'll point out is if you click on View Code, you can actually see all the files that are uploaded in your web space, and it should match the files that you've got locally on your computer. And you can see that the actual images are there in the resources subfolder. They're just not being made visible to my experiment. So we need to make them visible. The way we're going to make them visible is we're going to introduce a bit of code before the experiment even starts. And this code is only necessary for the JavaScript side, so the Python side is going to remain empty. But the code is this. We're going to add psychojs.start. It's a function that initializes our experiment, and we're going to, instead of just asking it to load in all resources, which it doesn't seem to be doing, we're actually going to be identifying all the resources we want loaded. So these should be actually .pngs. And so what we're doing here is we're creating a name that is going to identify our image. So over here, let's see here. This file name we're giving it, it's actually the name that that JavaScript is going to use to try and find our resource. So over here, let's see. That name's going to be resources/apple.png. Then we need to know the path of where whatever this is called is going to be, and it's in the same spot, resources/apple.png. We could have, for instance, just named things like that and said, okay, when you're looking for apple.png, look in resources/apple.png. And then over here, instead of identifying the folder, we could have just said, grab apple.png. And what this would have done is it would have caused JavaScript to say, okay, I'm looking for something called apple.png, and in the startup, it's being told, okay, that is actually in resources/apple.png. We could have just called this apple, and then we wouldn't have even have needed over here the .png. So we could have got rid of this too if we wanted. But I want to keep things as equivalent between my online and my offline version as possible. So I'm going to still label things with the full file name. And all that means is here, the names and the paths should just match up. So resources/apple.png. So let's see here. We had apple, banana, what do we have? Orange and grape. And we had red, blue, green, and yellow, I think. Memory serves correctly. And let me just fix all of these. Okay. So for each of these, and actually you can mess with the spacing if you want to have this be a little more readable. But for each of the images, I'm just identifying exactly where to find them. I can click OK now. And I can go ahead, oops, I click local run. That's okay. I'm going to cancel that and click web run. 4 files changed. We get our piloting error. And now when we click pilot, notice that we did start to download resources, but we downloaded 14 of 8. What gives? There's one last step that we have to go through here to make sure the preloading worked. But by the way, the fact that there was something that was preloading is a good indicator that it was actually trying to preload our images. The last step that you have to take if you use this technique for preloading things is that you have a function here called psychojs.start, which is preloading in a bunch of images. If you go to your actual raw JavaScript and scroll down a little bit, you will find your starting code. So here's our psychojs.start. But if you scroll down past the flow schedulers, you're going to find another psychojs.start function. This is actually, the fact that this is appearing twice is interfering with our ability to load in our 8 items. So we're actually going to comment this out. You could also just delete it. And here's where the fact that you can edit the JavaScript file after it's been produced from this is handy. Because after we've made this change, we can now sync this new file to Pavlovia, and that will fix our problem. So this code is, the auto-generated code is a little bit of a problem, and that's causing our problems for running the experiment. Now, I'll show you in a second that it's working, but I will say one downside to having this code in here is that every single time you click this play button, it's going to generate this again, and you'll have to come in here and comment this out. There's no way to forcibly comment this out forever. Now, if you look up the loading resources document on Pavlovia, there are other ways that you can load in specific resources. So you don't have to use psychojs.start. You can load things on the fly during the experiment. I found that you can do this, but if you're not careful with timing, it is always possible for subjects to skip through something where something hasn't finished loading, and then you get, the experiment will crash. So I like to force everything to load at the start. You get that nice progress bar showing the load to subjects. Just the downside is that you have to go in and make that little trim every time to the JavaScript file. But I prefer that so that I know that things are loading at the beginning. Anyway, if we go back now to pilot, now we will see our experiment loaded. And it was very fast, it went by very fast, but it only loaded 8 images. And now if we go into my experiment, it works just as I had intended it to. And there you go. That's the experiment. One other little tip I will point out to you is sometimes web browsers have a tendency to want to cache JS files from a website. So what this means is when you go to a website, you have to download the JS files that are on a website in order to run the JavaScript code of a website. And browsers like Chrome sometimes try and act in a smart way and say, hey, if there's a JS file that I already have, don't bother re-downloading it, just use the one I already have. And what this means, though, is that sometimes maybe you've made a change in your experiment and you upload it, and then you go to run your experiment on Pavlovia and it's still running an old version. You think, what the heck, did it not upload? So you go back in and you re-upload it again, and it's still running the old version. and then you come back into your dashboard and click on View Code, and you go and you find your JS file and you open it up and you look at it, and it's the new version that has the changes you made, but when you go to run it in your web browser, you're still getting the old version. Well, what's happening is locally on your computer, you have a JS file. It's an out-of-date one, but you have one, and Chrome just looks online and says, hey, it's the same name online. I'm not going to bother re-downloading it. And so you can get trapped in a state where you're just running an older version of your experiment, even when changes have been made. If that does happen to you, the way you get around it is you take your link for piloting and you open up an incognito window. In that window, you paste in this link, and you will always download the latest JS version and all the resources fresh when you are in an incognito window. The way incognito windows work in Chrome is that it doesn't rely on anything cached, and it will always download everything fresh and new, and it doesn't store things after you leave the website. So that is one other little bug you might encounter while trying to debug Pavlovia experiments. If it doesn't look like your experiment's updating, try an incognito window. It will typically fix the problem. Anyway, that's it for today's primer on how to run experiments on Pavlovia and typical problems that emerge. I hope this helps you guys get started. And if you have your own tips or tricks on how to get past common problems you see on Pavlovia, or maybe you have a better way of doing something that I showed you here today, feel free to post in the comments down below and share your tips with everyone. If you are in need of, special one-on-one help or further consulting services or something like that, my contact info is available down below. But again, I hope this primer is enough to get most of you started there, and especially sort of identify some of the more common problems you might encounter when running Pavlovia experiments. Anyway, that's it. Good luck with your research, guys.